Today I will discuss with you about the fifth chapter of your science book, that is gravitation. In this chapter, we will discuss about the force of gravitation, which are the cause of which are the factors of the gravitation, gravitational constant, the unit of gravitational constant, the relation between mass radius and the gravitational force, etc. The force of attraction. What is gravitation? The force of attraction between any two objects by virtue of their masses is called the force of gravitation or gravitational force. The force of gravitation exerted by a huge heavenly body such like earth, the moon or the sun, etc. on a smaller object near the surface is called gravity. What is Newton's law of gravitation? Newton's law of gravitation may be defined as every particle in the universe attract every other particles with a force which is directly proportional to the product of their mass and inversely proportional to the square of the distance between them. The direction of force is along the line joining the two particles. Now look at the picture. Here two particles A and B possess the mass of m1 and m2 and they are separated from each other by a distance r. Then the gravitational force F acting on the two particles is given by F is directly proportional to the mass of the objects, that is F varies m1 and m2. M1 is the mass of the particle A and m2 is the mass of the particle B, and also F varies 1 by r square, which is r. R is the distance between the two particles A and B. Combining two, we can get F varies m1 into m2 by r square, or F equal to g into m1 into m2 by r square, where g is called the universal gravitation constant. In this equation we can see that F varies 1 upon r square, that is the force is inversely proportional to the square of the radius of the two masses. If the distance between the two particles is doubled, then the gravitational force becomes 1/4. How can? When distances are, then force F varies 1 by r square. When distances 2 are, then F varies 1 by 2 r square. That implies that F varies 1 by 4 r square. If we calculate F by F dash, then or F dash by F, then we see the result F dash by F equal to 1 by 2 r square into r square by 1. Cancelling r square, we can get F dash equal to F by 4. So when the distance between two particles is doubled, then the gravitational force become 1/4. If the gravitational force between the two particles is half, then the gravitational force become 4 times greater than the previous one. For this you can see this relation. Why is Newton's law of gravitation called the universal law? The force of gravitation exists everywhere in the universe, even a small object along with a large object. Okay, Newton's law of gravitation hold good for all bodies, small or big. I have already discussed with that, terrestrial or celestial. Therefore, Newton's law of gravitation is called the universal law. What is the significance of Newton's law of gravitation in nature? The significance are for the existence of solar system, that is motion of planets around the sun. we can calculate the relation with the help of the gravitation. For holding the atmosphere near the surface on the earth, for the flow of water in rivers, for the rainfall and snowfall, everything we can explain by the Newton's law of gravitation. What are the properties of gravitational force? Gravitational force shows the following properties. Gravitational force is an action at a distance force. So from a huge distance with a huge particle along with a small particle or small object, we can calculate the gravitational force. This means the gravitational force always exist between two particles irrespective of medium. Gravitational force is directly proportional to the product of their masses of the particle and also the inversely proportional to the distance between the two particles. According to the Newton's law of gravitation, F equal to G into m1 into m2 by r square. For this equation, we can write that G equal to F into r square by m1 into m2. Thus, the unit of G would be depend upon the unit of force, distance and the mass. Then the SI unit of m1 and m2 is kilogram. The SI unit of F is Newton and R is meter. So the SI unit of G is Newton into meter square by kilogram into kilogram equals to Newton meter square by kg square, or according to exponential form we can write that Newton meter square into kg to the power minus 2. Okay, what is the value of gravitational constant? From the Newton's law of gravitation, G equal to, we can write that G equal to F into r square by m1 into m2. When m1 equal to m2 equal to 1 unit and r equal to 1 unit, then we can find the value of G or gravitational constant. Thus, the gravitational constant G is equal to the gravitational force which act between two bodies of unit mass, each separated from each other by a distance of 1 unit. The SI unit of mass is kilogram and the distance is meter. So m1 equal to m2 equal to 1 kg and G and r equal to 1 meter. So G equal to F, that means Newton. So G is equal to the gravitational force which act between two bodies of mass 1 kg of masses 1 kg, each separated from each other by a distance of 1 meter. Why G is called the universal constant? The value of G is independent of the nature, the size and the mass of the interacting body. Whatever the size, whatever the nature and the mass of the particles does not depend with the does not affect the gravitational constant. The space where the particle or bodies are kept, there is no reason that where you kept the bodies, the time at which the force is considered. Thus the value of G is same everywhere the body whether the interacting bodies are small or big, whether the measurement are made on Earth or any other planet. That's why G is called the universal constant.